Hello, good day viewers. In today's tutorial we are going to see the principal quantum numbers. Today we shall see the principal quantum numbers. So what is principal quantum numbers? This principal quantum numbers, it is a numbers that describe the energy level of an electron that is inside an atom. Let's say we have this, n it is equals to 1, n it is equals to 2, and n it is equals to 3. So let me write the definition. So therefore this number, it describes the energy level of an electron inside an atom. So n it is equals to 1, n it is equals to 2, and n it is equals to 3. So therefore in this quantum number there is what that we call the angular quantum number. So in angular quantum number, what is angular quantum numbers? Angular quantum numbers are numbers that describe the shape of a sublevel with an energy level. So therefore we have the S of shell, and we have the P's of shell, and we have the D's of shell, and we have the F's of shell. So as you can see, S of shell, it is equals to what? S of shell is equals to 0, and P's of shell, it is equals to 1, and D's of shell, it is equals to 2, and F's of shell, it is equals to 3. So what I mean is that the value of the value of L it is equals to 1, L it is equals to 0 in S of shell, and L it is equals to 1 in P's of shell, and L it is equals to 2 in D's of shell, and therefore L it is equals to 3 in F's of shell. Let me illustrate them. Let's say this is this is S of shell, and this is sorry for my sketch, this is the piece of shell, and this is the D's of shell, this is the D's of shell, and this is the F's of shell. So this is how they look. This is the angular quantum numbers. The angular quantum numbers, we have S of shell, P's of shell, D's of shell, and F's of shell. And S of shell, L it is equals to 1. L is the same thing as equals to 1, and therefore L of shell in P's of shell, L it is equals to S of shell. The S of shell, L it is equals to 0, the P's of shell, L it is equals to 1, and the D's of shell, L it is equals to 2, and the F's of shell, whereby L it is L it is equals to L it is equals to 3. And you have to take note that L it is less than or equals to n minus 1. When n it is equals to 1, n it is equals to 2, n it is equals to 3. So what I mean here is that if n it is equals to 1, so therefore n which is n minus 1, which is 0, so L it is equals to 0. So this is this is S of shell. So but when n it is equals to n it is equals to 2, this is the same thing as saying 2 minus 1, which is equals to 1. So I'll have 0 and 1, which means S of shell and P's of shell. When n it is equals to 3, this should now be I have to say what is the value of n? N as 3 minus minus 3 minus 1, which is equals to 2. So therefore I have to start from 0, 1, and 2. So therefore this is S of shell and the D's of shell. But if n it is equals to 4, this is the same thing as saying 4 minus 1, which is equals to 3. So I'll have only three numbers. So this should now be 0, 0, and therefore I'll have 1, I'll have 2, I'll have 3. This it means that I will go off to 3. So this is S of shell, P's of shell, D's of shell, and and the F's of F's of shell. Suppose I am given 3D. I'm asked to identify what? I'm asked to identify the N and what? And L. So as we all know that this whole number 3 is what? It is N. Whenever you are given this question, so the 3 it is what? Is the same thing as N. So what of D? What of D? We have to take a look at S, P and D. D is what? So therefore D has L as what? As 3. So therefore this is the answer. So first I am giving 4F. As we all know, N it is what? It is 4. N it is equals to 4. So what of F? What is L? 0, 1, 2, 3. So F is 3. So therefore L it is equals to what? It is equals to 3. So let me talk about the magnetic quantum numbers. Magnetic quantum numbers known as what? The ML. So whenever I have L is equals to 0 and I have what? L is equals to 1 and I have L it is equals to 2, L it is equals to 3, L it is equals to what? L it is equals to 4. So what will be the magnetic quantum number? The magnetic quantum number of this will be 0. The magnetic quantum number of L it is equals to 1. This shall now be minus 1 and what? 0 and 1. Magnetic quantum number of this shall now be what? Minus 2, minus 1, 0, 1 and what? 2. And therefore the magnetic quantum number of 3 shall now be minus 3 and therefore shall now be what? Minus 2, minus 1, 0, 1, 2 and 3. Magnetic quantum number of 4 shall now be what? Shall now be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. So first I am giving an example. Let's say 2p. So as we all know, let's say 2p and 4, let's say 4d. So this is what? This is the whole number known as what? The value of N, which is what? Which is 2. And the P, which is L, SP, L it is equals to what? L it is equals to what? L it is equals to 1. So for L it is equals to 1, let's say 2 feet should not be. L it is equals to 1 in magnetic quantum number. We have, so I have to say dash, dash and dash. I have negative 1, I have 0, I have 1. So that's for what? That's one of the examples for magnetic quantum numbers. Let's say for 4D. As we all know, N it is what? N it is 4. And what? L. What is L? D. I have S of shell, P of shell and D of shell, which is equals to 2. So this is what? L it is 2. So as you can see, I have to take the magnetic quantum number and see where is L it equals to. When L is equals to, I have minus, 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 minus. Where I will fold the minus 2, minus 1, 0, 1 and what? And 2. So the next thing that I'm going to tell you is the electron spin. Electron, which is what? The electron spin. So what is electron spin? The electron spin, which is known as the MS, whereby it is indicating either what? Upward or what? Or downward. So what I mean by that is that, suppose I am giving an example, 2p what? So this up and down, it is indicating what? Plus. When it is up, it is equals to what? Plus a half. When it is down, it is the same thing as what? Negative a half. So therefore it is plus or minus a half. The MS, which is the same thing as what? Plus or minus of what? Half. Let me give you an example. An example under this. So first I am giving what? I am giving 3d8. 3d raised to the power of 8. So you all know that N here, N it is equals to what? N it is equals to 3 and D, what of D? S, P and D. D, which is L, it is equals to 2. And therefore, you have raised to the power of 8. So in this, we are going to apply 3 things. As we apply the first example that I delete here, whereby you will only find this and this, N and what? L. And therefore, you have to apply the magnetic quantum number, which is what? The L, which is 2. So I have to say minus 2, 1, 2, 3, 4, 5. 3, 4 and what? And 5. So I have minus 2, I have minus 1, I have 0, and therefore I have 1 and I have what? I have 2. So the next thing is that this raised to the power of 8, this is the electron spin. So I have to count. This is 1, this is 2, this is 3, this is 4, this is what? 5. This is 6, this is 7, this is 8. So therefore the electron spin is at what? 0. And therefore this is what? Negative what? Negative a half. So if I am to take a look to this, it is what? Negative a half. We take another example. Suppose, let's say I am given what? 3, let's say 2, let's say 2p what? 2p3. So n it is equals to 2 and l it is equals to 3. So 1, I'll have 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Since L it is 3, so I have to take a look to the magnetic quantum number. I have to say 2, 3, 4, 5, 6, 7. So I have to say minus 3, minus 2, minus 1, 0, 1, 2, and what? And 3. So I have what? Only that's the power of 3. So I will say 1, I will say 2, I will say what? 3, and I will say, okay, it is only what? It is only 3. So therefore this is at what? At the point negative 1. At the magnetic quantum number ml, the ml which is negative 1, and therefore the ms should now be equal to. So at the end, if you are given this, you will say n it is equals to 2 and l it is equals to 3, and therefore what? The ml at this point it is equals to negative 1, and therefore the spin quantum number it is going up, so therefore plus what? Plus a half. So this is one of the questions that in question you might be seeing. So therefore I hope this is clear for you. The power, it is indicating how many times you are going to put what? You are going to put the arrows, and therefore when you comes to an end, you are going to be putting it downward, 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 downward. So this is all I have for you for the principal quantum numbers. Please don't forget to subscribe to this YouTube channel. Thanks you for watching. Have a nice day.